So yeah, question 49 from the homework, we've got silver sulfate. They give us the KSP of silver sulfate, 1.2 times 10 to the minus 5, and then say, basically we have this silver sulfate in the presence of silver nitrate. So this is actually very similar to the deliverable for the week after spring break. And we have 0.1 molar silver nitrate, which basically means in our ice table, from the silver nitrate, we're going to have 0.1 molar silver. From the sulfate, right, we have 0 sulfate to begin with. And then sure, we're going to get X, we're going to get 2X amount of silver from the silver sulfate. We're going to get X amount of sulfate from silver sulfate, but that's small enough that we can ignore that and basically say, okay, 0.1 is my concentration of silver and my concentration of sulfate is X. So plugging that into my KSP, well, I'll give us our KSP expression first. Concentration of silver squared because of that coefficient 2 times my concentration of sulfate. So that KSP 1.2 times 10 to the minus 5. Concentration of silver is 0.1 squared and sulfate is my unknown. So 1.2 times 10 to the minus 5 equals, so that should be 0.01. Yeah, 0.01 times the concentration of sulfate. Divide both sides by 0.01. That cancels out, and my concentration of sulfate ends up being 1.2 times 10 to the minus 3 molar. So that's the concentration of sulfate in solution with the common ion present. And if we look at this, the molar solubility of silver sulfate, right? The question asks, what is the molar solubility? The molar solubility of silver sulfate is X. Because basically for every 1 mole of silver sulfate that goes into solution, I'm going to get 1 mole of sulfate because they form in a 1-to-1 ratio. So my molar solubility of silver sulfate is also equal to that 1.2 times 10 to the minus 3 molar. Because that's the concentration of sulfate in solution, that also tells me how much silver sulfate was able to go into solution.